Hello, so today I want to implement a depth first search into Python. It's going to be something very basic, nothing too complicated, just because what I want to understand better the depth first search, so I did that, and then maybe later on I'm going to go into breadth first search or more complicated implementation of a graph, maybe like creating some node classes, linked lists and stuff like that, and then apply those depth first search concepts to those more complicated data structures. But first, basic stuff. We're going to go with a dictionary of nodes, every key being a node, and every value being the children of the node. Okay, so how is that going to go? You have a main node, the root. Okay, is going to split in multiple nodes like so. And then your node here is going to have one of many children until there is none anymore. So what does the depth first search want to do? It's going to visit every node of your graph at least once. How so? Well, you put the first value you want to go through, usually the root here, and you want to know that you have visited it. Then you're going to search anyway, like there is no direction, no priority specifically defined as for a depth first search. So basically we could just go for the first way here and visit that node, and then go same thing, visit the node, deeper, visit the node, reach the end, go back. And when we're going back, that's where it's getting interested, right? It's interesting because you're going back and you're like, I have visited it, so I keep going back. I have visited it, but there is another child to that node, and I'm visiting it. This is another leaf, so I'm gonna go back up again and visit it like so. Here, and leaf, so go back up, etc., etc. So what you can see here is that depth first search just inherently doesn't do anything specific aside from visiting every node once, and it is a very basic way of saying you're going to recursively call your function. Because in the end, what is this movement is just go deeper as long as it's not a leaf or as long as it's not visited, else go to the next direction. And so that isn't also a nice way to see your first recursive call. So how would I describe a recursive call very fast? It would be like a func that would take x as an argument, and it could be like if x is smaller than 10, then x plus equal 1. Okay, and then return, and that's when it's interesting, return func of x. So what's going to happen here? Well, every time you're going to be like, if x is smaller than 10, I add 1, and I call func again, add 1, until you reach 10, and then nothing happens and it stops. So maybe you want to do a else statement just returning x, and so what is going to happen here is that if you run this, you're going to get basically 10 whatever you do, right? Okay, better like this. So this is a recursive call, alright? You're calling the same thing to happen until something that you want as a key is happening. And for us, this something, this test, is going to be either that the node is a leaf or that it's been visited. Okay, so first of all, how are we going to follow up on the visited node? Well, we're going to create a dictionary of visited nodes, and we're going to generate it like so. So n being the keys of the graph is going to be equal to false. Okay, so for n in graph. Okay, basic list comprehension. So I'm not going to go deeper into that. There's things I learned this week about that. And then let's go with our depth first search that is going to take an argument with a start node. And let's say Now here we are in our recursive call. So the first thing we're going to test is whether or not we are in a situation where we can do our call. And we saw that one of the two biggest situations we want to test out is if we have visited that node. So if visited of start, which is the node that is being visited, equal true. But don't forget that we have false values in there, so you don't need to test that. So it's just like if the value is false, it's not going to be true. So it works. Then we're going to return. Okay, so we don't want to visit a visited node. We want to go to the next layer, the next child that we are visiting at that point. This is going to get more clear later on. So if we haven't visited that node, then what we're going to do, well, say just visited. So visited of start, okay, equal true. I cannot write down true for my life, I'm sorry. And now we're going to create a new object, and that object is going to be what? Well, it's going to be the children of that node. So children equal to graph of start. My bad. So graph of start is going to give you a tuple, okay, of values, and those values are all the children you want to visit from that node. So let's start it out like so. But you can see that I chose to use a tuple of a single zero value for every leaf of the graph, and there's a little detail to understand, and it's that a tuple of one single value is an integer, and a tuple of a single value with a comma is a tuple. So those structures are not tuples. You cannot iterate through them. They're not iterable objects. So if I want to test out here that I am not reaching a leaf, like I visited that node, okay, now I said it's visited, and I want to take its children. But if that node is a leaf, then it doesn't have any children. It has this zero value. So I'm just going to say if not children. Okay, that makes sense because this is not a tuple, it's a value of 0, which is false. So if not children, okay, we're going to return because we don't want to stay, we don't want to do anything else. We visited that node, we're done with it. So let's get away from here. But if it's not, for every child in children, we're going to visit this child if it wasn't visited. So if visited of child, return. Else, and this is the recursion, if we haven't visited that child, we want to visit it, so we're going to call DFS of child. Okay, and that's it, we're done. Okay, here we are iterating through every child of the children. Oh my god, we're iterating through every children of every node until we're done, and we don't have anything to do anymore. And then we're gonna return. Okay. And then when we're out of all those loops, we're gonna return completely. And here we are visiting every node in our list, and to make sure that we are, I'm going to make something like so print visited, and then we're going to call DFS of 1, and then we're going to print visited again. When I got exactly the problem I told you earlier, like if they say that the int object is not an iterable on line 25. Okay, so I found out the little issue, so I just explained it to you when I did that mistake. Here I had a lonely 8 linked to that 7, right? And so it wasn't an iterable object, so now it's solved. So let's go and run this again. So what we're gonna have is this. you see that we have visited everything, because first we start with a full false dictionary of values, and then everything visited after we run the fs. So we have done it. Okay, but we should do something with that depth first search, right? So for that, we're going to keep track of something with a result variable that is going to be a list. And let's say that maybe I want to just get all the values, okay? So where do I put that variable? Well, if it was visited, then I don't have to do anything with it. I visited it already. If I'm visiting it, then I want to do something. So res.append start, okay? And what if I run it like so? Well, I want to return this new value every time, okay? So I'm going to return res everywhere to be sure, and return it here. So why do I do that? Because now if I just print my DFS of 1, I'm going to return the value I want. So let's go with this. And exactly, our list is now exactly following the path that I wanted it to. So 1, 2, 3, 4, 5 through 13. So this is our depth first search. Let's try something else. Maybe I want to identify the leaves only. So what I'm gonna do is remove it from here and there, put like if not children, then res.append start, and just go as that, and magically I get the leaves of my graph. Do we want to check it out? Well, 4 is here, no, is a leaf. 5 is a leaf, 6 is a leaf, 8 is a leaf, 10, 12, 13 are leaves. So it's working out pretty good. So that's it for our basic depth first search. Like you see, there's nothing crazy in this algorithm, but I felt like I needed it. As a little bonus though, I'm gonna do something that might help people now understand that I use a lot, and that's why I'm in PyCharm right now, even if I'm trying to go into more simple, like basic IDEs. It's for its debugger. So let's see. Here we're gonna check this out. We're gonna check visited children. Okay, and then we're gonna see for child in children, and I guess that should be enough. Let's see if that's good. So here we are in the debugger. So what is going on? We see that we are in start is 1, then visited equal true, children graph of start, okay, and we see that here children is 2, 7, and 9, so a tuple of 3 values. And then for child in children, and child being 2, if visited child, it's not visited. Maybe I'm gonna add a point here. We're gonna call the DFS of child, and so we're back up there, and its start is now equal to 2. It's not visited, so we're going down to making it true. Then the children equal graph of start, so 3 and 6. There is children, so we go next to the else statement, and for every value in here, so 3 and 6, being 3 first, is it visited? Well, it's not, so we call DFS of 3, and boom, we're back up. Same thing, true, take the children, new children, if not, well, they are, else, for child and children, if it's visited, it is not, we call DFS, and then here, 4 is a leaf. So, was it visited? Yes. Not yet, sorry. Now it is visited, sorry. Children of graph, well, nothing. It's 0, so if not children, where we append this node to the list and we return our new list. So here we went back up, so it means that we finally had the result of the previous iteration of my DFS, okay? So that's why we end up here, we come back up here, we get the result, and so we're gonna finish that first loop. And so we're gonna go through the next child. So you see here you changed into the new child, so for child and children, 4 and 5, you go now into the 5. So what happened is what we said earlier, right? We did this, okay, and here we had 4 and 5. And so you visited everything up until 4, went back up, and now you're visiting 5. That's what's happening. My bad. So now that we're visiting 5, we are done, so we're going back up, and so we now have a value of 5, which was the parent of our sorry, now we're studying 5, I'm getting lost myself, and this 5 is a leaf, so we are appending it, etc, etc. Now we're done with those children, so we're going back up to the 3, we're done with it, so we're going back up to the 2, see the start up there, that's changing, and we're done with it, so we're going to 6, etc, etc, and so we're done. So that's basically what's happening in there. This was a little bonus visualization tool I wanted to use. So yeah, thank you for your attention and keep on coding. Bye.